Hi, welcome to part 2 of this devlog for version 0.0.7. In the last video we covered the weird glitching that was occurring because of an old, parallelized implementation of a region sync setup, making that syncing faster and updating of the model data faster as well. This one is going to be a shorter one. Hopefully going forward, future updates will be about this long. Anyways, let's dive headfirst into this. So, as I was testing out the tool's clip implementation, I found this weird problem where as I moved away from the origin, the region that was rendered would jump farther and farther away from the player instead of being centered with the player. I tried for several hours to fix that and did a whole bunch of experimentation with the transformations being applied to the region float grid compared to the world float grid. I could not, for the life of me, figure out what was being misapplied during the sync process so that the world position of the region float grid origin was not equal to the player position. Then I remembered something I read when I was looking through the documentation in the last video, and that was that I could set each voxel to be active or non-active, and I can check for the state of the voxel. I think you can see where I am going with this. To start off the implementation, I removed the old region struct that contained the region float grid, the VBO, the VAO, the EBO, as well as the verts, indices, normals, and colors vectors. I made the VBO, VAO, EBO, vertices, indices, normals, and colors all private members of the world class, and I removed the region float grid. I then moved my attention to updating the sync function. I started by creating a chord of the player's position. I had to divide the player position by the voxel size to scale the player position to the voxel grid. Like the previous implementation, I calculated a min and max coordinate based on the player position and the render distance. Then I took these and created a bounding box from them. Moving on to the major changes. I used the tools for each from OpenVDB to efficiently utilize the float grid iterators that are provided by OpenVDB. This allowed me to have a parallelized for loop that will run the following algorithm. The algorithm will check if the current voxel is within the bounding box and not empty, and set its state to active. If the voxel is not within the bounding box and also not empty, its state would be set to inactive. But that's not all the changes. I also had to change the world initialization function so that setting a voxel value would not affect its state, which by default is inactive. I accomplished this by using the method setValueOnly. I also changed the gen region mesh function to iterate through only the voxels that were set as active by using the begin value on iterator. And finally, as you can see here, it is working splendidly, and the rendered area follows the player and is nicely centered on the player. It also runs fast and doesn't drop the frames low, and as I have been told by beta testers, it runs smoothly on integrated graphics as well as on a dedicated GPU. Thank you for waiting for and watching this video. I am currently working on version 0.08 where I will be adding block types, pseudo-random terrain generation using Perlin noise, collisions and basic physics, and world manipulation, as well as a lot of refactoring mainly for the player and camera classes. Check out my Twitch to watch me code, game, and other stuff. I don't know yet. All that's live. Twitch is live. I live stream. You should watch. It's fun. Also, I post mountain bike videos, and I'm going to be posting some cinematic snowboard videos, so stick to that. Stick around for that. I'm recording this at like 1 in the morning, so if I sound tired, that's why. Anyways, have a good day.